Now that we've talked about what an equation is, we're going to talk about linear equations. So, what is a linear equation? It is an equation that represents a line. An equation that represents a line. Let me give you an example. Y equals 2 times x, or 2x, minus 1. So this is an example of a linear equation. And like any equation, it can follow our model of something equal to something else. We have what's on the left, y is equal to 2x minus 1, something equal to something else. And what's new here is that we have two variables. We have an x and a y. So this is a new concept. How about we just play with this? Let's see what we learn. Let's say we took off the mask for x and we found out x equaled 1. Then what would y equal in that case? Well, using our equation, y equals 2 times our x, which is 1, minus 1. 2 times 1 is 2, and our answer is 1. If x equaled 1, then y equals 1. And so we say that x equals 1, y equals 1 is a solution to the equation. X equals 1, y equals 1 is a solution to the equation. What does that mean? In other words, we say that x equals 1, y equals 1 makes the left side of our equation equal the right side. We have our equation up here. We picked an x, and we found the y such that the left side, which is y, equaled the right side. We plugged in our x and found what our y would be. So that's what it means to be a solution. It's something that we can plug back in to our equation, and the left side would equal the right side. So let's go ahead and do that, just as an example. We have x equals 1, y equals 1, and let's just plug that in here. So replacing x and y, we'd have 1 for y equals 2 times 1 minus 1. And what does that lead to? That leads to 1 on the left, and then 2 times 1 minus 1, which is just 1. It's considered a solution because it maintains that equality for our equation. And as I mentioned, this is a solution, and it's important to emphasize that it is a solution because we just picked this x equals 1. We could have picked a different number. And let's try that. What if we said x equals 2? Let's say we took off the mask and x equaled 2, for example. What would y equal? Well, y would equal, using our equation, 2 times x, which is 2, minus 1. That equals 4 minus 1, which equals 3. In a similar way, we say, so x equals 2, y equals 3 is a solution to the equation. It is a solution, meaning it's a pair of numbers for x and y that we can plug back in into the equation to make the left side equal the right side. Let's try one more example. Let's say x equaled a negative number. Let's say it equaled negative 2. what would y equal? Well, again, we use our equation at the top, and we'd have y equals 2 times -2 minus 1. And as you see, I put this -2 in parentheses. It helps to use parentheses sometimes to make our math look a little clearer. Instead of writing 2 times -2, having this dot right next to a minus that negative sign, it can be a little confusing. So parentheses are known as grouping symbols. You can group some stuff together, and so that's what we're doing here. Confusing. So that's why we're using the parentheses. So 2 times -2 is -4 minus 1, and that equals -5. So one more time. This might seem a little tedious, but there's a purpose. So we have x equals -2 and y equals -5 is a solution to the equation. A solution. So now we found 3 different solutions, 3 different pairs of x and y that make our equation true, that make the left side equal the right side. So how about we try to find a way to visualize this? Sometimes making a little picture of what's going on in math can help you to connect the dots. I'm going to draw a couple lines here. And let's say we're going to have one line for our y's, our y values, and then the other line is going to have our x values. And let me make some little tick marks here. So positive x values go this way, negative x values go this way, and positive y values go this way, and negative y values go this way. And we're going to use it to try to visualize our different solutions here. So we have x equals 1, y equals 1, x equals 2, y equals 3, and x equals -2, y equals -5. I'll write down our 3 solutions that we want to place on this chart. For our first solution, we have x equals 1, y equals 1. So what we do is we start at this center of our 2 lines, and we're going to walk on this x line. X equals 1, so we're going to walk on the blue line over to 1. And then we're going to walk up 1 for our y value. See, positive x values go to the right, and then positive y values go up. And there we will place a dot right here. And this dot represents x equals 1, y equals 1. So let's do that for our other 2. So we finished this one. Let's move on to the next one. X equals 2 and y equals 3. So x equals 2 means we start again at this center dot, this center point where these 2 lines cross, and we'll walk on the blue line 2 points that way for our x, and then we'll walk up 3 points for our y, and then we'll place a dot there. And that point is going to be our x equals 2, y equals 3 solution. And finally, our last point here, our last solution, we're starting at the center, and we're going to walk 2 steps that way for our negative x, and then negative y means we go down 5 units. and then we place our dot here. These are our three solutions. And if you notice, all of these three solutions fall on a line. There you go. And that is the point of a linear equation. We are forming a line. Remember, we said a linear equation is an equation that represents a line. And we have formed a line. So let's take a step back. This is a lot of information. Let's take a step back to write some notes about what we did. So we tested out some different x's, right? We just picked an x and then found out what y was. And so those formed solutions. And we had our three solutions. And then each of them, each solution, each pair of x and y is a point on the chart. And what's our rule for plotting these points? We start at the center, where that x line, those blue x line and the blue y line, where they cross, start at the center, and move left or right for the x value, and up or down for the y value. And that's how we plot these solutions on this chart. And we can draw a line through them. And now let's move back to a point that I brought up earlier. We said that each of these points is a solution. A solution. And we plotted each of these solutions. So that brings up a question. How many solutions are there? Whoops, I forgot to mark our point here. X equals -2, y equals -5. Okay, so how many solutions are there? We picked 3, but couldn't we keep picking more? Couldn't we just keep picking more x's and finding more y's? We could, and we could do that forever. So there are an infinite number of solutions. You can always pick a new x and get a new y. And here's the drum roll moment. As we said, we looked at each of these as a solution. And if we consider all the solutions, we form the line. All of the solutions form the line. So if we keep on picking x's, let's say, for example, we picked an x that went this far. We went to -1, and then we plugged that into our equation. We would end up coming down here and putting a point right here. And so you can keep picking x's, and then you would end up forming more and more and more and more dots. And all of these dots, these infinite dots, that is what forms the line. That is what our linear equation tells us. It tells us when you consider all of the x's that you can put in here, we just picked 3 right here, remember? Well, when you consider all the x's that you can plug in there, and then all the y's that come out of that, that forms these pink dots, that forms this line. So it's a little tedious to, calculate all of these dots. We did our 3 examples, but it's kind of tedious to have to draw many, many examples like this and make many pink dots. So usually, if we know we're looking at a linear equation, then we'll just find 2 solutions, 2 points on our graph, on our chart, and then draw this green line through it. And we can say that all of the solutions will fall on this line. Well, if you notice, that brings up another question. How did we know that our y equals 2x minus 1 was a linear equation? Well, because I told you it was. And also the title of this video is linear equations. So there's a good chance we're looking at linear equations. Let me give you a better question. If you were out in the forest and you saw a tree, let's make a tree. Let's make a nice tree. And on that tree, someone has carved y equals 2x minus 1. Well, let's carve something else too, something typical. Let's say this y equals 2x minus 1 is right underneath Bobo Hearts Susie. Okay, so you see Bobo Hearts Susie, should make sense, but then you see y equals 2x minus 1. So I'm not there, it's just you. How can you tell, looking at y equals 2x minus 1, that that is a linear equation? That if you just plot 2 points on that graph, that you can just draw a line and be confident that you have a line, that you know what this equation is? Well, if you want to know how to figure that out for yourself, and also whether Bobo truly does heart Susie, meet me in the next video.